Good day everyone! Teacher Hani here, and today I am going to teach you how to solve rational equations and rational inequalities. Grab your pens and papers now and let's get started.
Let us begin with how to solve a rational equations. When you are trying to solve rational equations, I want you to remember 4 simple steps. First, look for the LCD or the least common denominator. Second, multiply this LCD with both sides of the equation. Third, solve for the unknown. And finally, check your answer.
Consider our first example. 2 over x minus 3 over 2x is equal to 1/5. To solve this, first, we need to find the LCD or the least common denominator. In here, the LCD is 2x times 5. Next step is to multiply this LCD with both sides of the equation. We have 2x times 5 times the quantity of 2 over x minus 3 over 2x is equal to 1/5 times 2x times 5. Third step is to solve for the unknown. When we multiply this LCD with the first term here, we can see that x here can be eliminated, leaving 2 times 5 times the numerator 2, this one, minus, if we will multiply this LCD with this term here, we can see that 2x here and here can be eliminated, leaving 5 times the numerator 3, this one, is equal to, on the other side of the equation, we can see that 5 here and 5 here can be eliminated, leaving 1 times 2x or simply 2x. Simplifying further, we have 2 times 5 times 2 is equal to 20 minus 5 times 3 is 15 is equal to 2x. Furthermore, we have 5 is equal to 2x. Finally, to solve this, we have to divide both sides by 2, like this one. And finally, we have x is equal to 5 over 2. Now for the final step, we need to check our answer. For x is equal to 5 over 2, all we need to do is to write our rational equation and substitute the value that we have here to all the x that we have in the equation. Just like this one. We have 2 over 5 halves minus 3 over 2 times 5 halves is equal to 1/5. Simplifying this, we have 2 times 2 over 5. This 2 over 5 here came from the 5 over 2 there. We multiply it with the reciprocal of the denominator since multiplication is the opposite of the division and it is easier this way. Continuing, we have minus. We have this denominator, we can see that 2 here can be eliminated, leaving 3 over 5 is equal to 1/5. Simplifying further, we will have 2 times 2 is 4 over 5 minus 3 over 5 is equal to 1/5. And finally, we get 1/5 is equal to 1/5. Now that we have checked that both sides are equal, then we can say that x is equal to 5 halves is a solution of our rational equation here. Okay, let us try to solve another rational equation. X over x plus 2 minus 1 over x minus 2 is equal to 8 over x squared minus 4. To solve this, our first step is to find the LCD or least common denominator. In this equation, we could break down the denominator of this term into its factors x plus 2 times x minus 2, just like this one. Next, we could clearly see now what is our LCD, and that is x plus 2 times x minus 2. Second step is to multiply this LCD with both sides of the equation, just like this one. Next step, we have to solve for the unknown. When we multiply this LCD here with the first term here, we can see that x plus 2 can be eliminated, leaving the numerator and this one, x times x minus 2, minus, if we will multiply this LCD with this term here, we can see that x minus 2 here and x minus 2 here can be eliminated, leaving the numerator 1 and x plus 2. So 1 times x plus 2. On the other side of this equation, we can see that these denominators here and this LCD can be eliminated, leaving only 8 in this side. Simplifying further, we have x times x is x squared, x times negative 2 is negative 2x, minus 1 times x is x, and 1 times 2 is negative 2. We have negative 2 here because we included this sign here of the operation minus to the sign of our 1. So distributing it, negative 1 times 2 will give us negative 2 is equal to 8. Now next, we need to combine similar terms and we will equate this side with 0. We have x squared minus 3x from negative 2x minus x minus 2 minus 8. Take note that this 8 here came from the other side, and if we move a number from other side of the equation into the other side, observe that the sign of that number will change, just like this one. Simplifying further, we will have x squared minus 3x minus 10 is equal to 0. Now, we could solve for x. In here, we have a quadratic equation, and this equation here can be factored. If it happens that you find a quadratic equation that cannot be factored, you may use quadratic formula. So, but in here, we can factor it, and the factors are x minus 5 times x plus 2 is equal to 0. So, next step is to equate each of these factor into 0. First factor, we have x minus 5 is equal to 0 and solve for x. X here is 5. Next factor, we have x plus 2 is equal to 0. Solving for x, we have x is equal to negative 2. Now for the final step, we have to check our solution. First solution, we have for x is equal to 5. Again, we have to write our rational equation. And then substitute the value that we have here into all the values of x found in this equation, just like this one. 5 over 5 plus 2 minus 1 over 5 minus 2 is equal to 8 over 5 square minus 4. Simplifying it, we will have 5 over 7 minus 1 over 3 is equal to 8 over 25 minus 4. Now you can see that in this side of the equation, we have a dissimilar fractions. To simplify this, we need to make this a similar fractions by applying their LCD. For this one, we have 21. So 21 divided by the denominator here, 7 is 3 times the numerator, so 3 times 5, this one. Minus 21 divided by 3 is 7 times the numerator 1, so this one is equal to 8 over 21. So simplifying it, we will have 15 over 21 minus 7 over 21 is equal to 8 over 21. Finally, we got 8 over 21 is equal to 8 over 21. Now, since our resulting checking for this is equal to each other, we can say that this one is a solution of our rational equation. For the next value of x, which is x is equal to negative 2, again, we will write our rational equation and then substitute all the values of negative 2, replacing all the x here. There. square minus 4. Now, as you can see, observing the denominator of this one, negative 2 plus 2 is 0. Also, on the other side, we will have 8 over negative 2 square is 4 minus 4 is 0. Now, we need to stop here because a fraction should not have a 0 denominator. Otherwise, it will become undefined. In this case, we have an undefined solution. Therefore, we can say this one is not a solution for this, and we call it as an extraneous solution.
This time, let us pause for a while for a practice. Solve the following rational equations in 10 minutes. Answers can be found at the end of the video.
This time, we're now ready to move on with our next topic, which is solving rational inequalities.
For our first example, consider this inequality. 2x over x plus 1 is greater than or equal to 1. To solve this, our first step is to make this right side of the equation equal to 0. So we have 2x over x plus 1 minus 1 is greater than or equal to 0. Now observe that when you move a number to the other side of the inequality, notice that the sign changes. So from positive to negative 1. Next step is to make this right side here a single rational expression. To do that, we can use the LCD. In here, our LCD is x plus 1. So LCD divided by denominator x plus 1 times numerator 2x, so we have 2x. Then we have minus LCD divided by 1, because it is understandably that a whole number have a denominator of 1. So again, we have x plus 1 divided by 1 times the numerator. So we have minus 1 times x plus 1 is greater than or equal to 0. Then let us simplify this one. We have 2x minus x. This came from negative 1 times x minus 1, and that is from here, negative 1 times 1. All over x plus 1 is greater than or equal to 0. Simplifying further, we will have this. X minus 1 all over x plus 1 is greater than or equal to 0. Now, we can go to the next step. Our next step is to find the critical points. To find the critical points, all you need to do is to look at the numerator first and then the denominator second. First, for the numerator, we need to equate this with 0. X minus 1 is equal to 0. And so for x, we have x is equal to 1. Next, in the denominator, take note that the denominator should not be equal to 0. Otherwise, it will become undefined. So, x plus 1 should not be equal to 0. So for x should not be equal to negative 1. Next step is to graph these critical points in a number line. So we have here. Next, we will put an empty circle for negative 1 since negative 1 should not be included. Next, a shaded circle to positive 1 since that critical point can be included. We have here. Next step is to determine the sign of the function at interval determined by the critical points. So let us determine. In this side of our number line, so from 1 to positive infinity, select a number. You can have 2, 3, 4, 5, or 6, or even 100 or 1,000. But I'll be choosing 2 because 2 is nearest to 1. So next, this 2 here should be plugged in our expression here in this side so that we can determine the sign of the function. All we need to do is to substitute this to all the value of x there. We will have 2 minus 1 all over 2 plus 1 is equal to 1/3. Now observe that this 1/3 here has a positive sign. Then we will put the sign here. Okay. Next, in this interval here, from negative 1 to 1, we have to choose again a number. I am choosing 0. Again, plug in this number to our rational expression here to find the sign of the function. So we have 0 minus 1 all over 0 plus 1 is equal to negative 1 over 1. Again, observe that this number has a past negative sign. So you put the negative sign here. Last, in this interval, you choose numbers that are less than negative 1. Again, you can choose any number less than negative 1. It can be negative 5, negative 10, or so on. I am choosing negative 2 since this is nearest to negative 1. So again, plug in this to our expression there and find the sign. So negative 2 minus 1 all over negative 2 plus 1 is equal to negative 3 over negative 1. And again, observe that these numbers gives us a positive sign. So we put the positive sign here. Now, next step is to write the solution. To choose a solution, go back to our indicator here, the sign. So it says that this one should be greater than or equal to 0. And numbers that are greater than or equal to 0 are positive number. So we can say that all of these in here are our solution. So to write it, you can have it this way. Solution set is from negative 1 to negative infinity. It is a parenthesis because negative 1 is not included. And then or we have positive 1 to positive infinity. It is a bracket here because positive 1 can be a solution. So that's it. Or you can write it this way. Solution set is x is an element of all real numbers such that x should be less than negative 1 or x should be greater than or equal to 1. Consider this next example here. X over x plus 2 minus 1 over x minus 2 is less than or equal to 8 over x squared minus 4. To solve this rational inequality, first, we need to make this right side of the inequality equal to 0 by moving this to the other side, just like this one. Observe that when we move this, the sign changes from positive to negative. Next step is to make the left side, this one, of the inequality a single rational expression. So as you can see, you can break down this denominator of 8 here. Let's have x plus 2 times x minus 2, just like this one. Next, to simplify this, we have their LCD, which is x plus 2 times x minus 2. If we will divide this LCD to this denominator here, we can see that x plus 2 will be eliminated, and then the remaining will become x minus 2 times the numerator. So this one, minus, dividing the LCD here with this denominator here, we can see that x minus 2 can be eliminated, leaving x plus 2 times the numerator 1 there. Thus, this one. Minus, if we will divide this LCD with this denominator here, these factors will be cancelled, times the numerator that left us with 8 here is less than or equal to 0. Now let us simplify this further. We will have x times x is x squared, x times negative 2 is negative 2x, negative 1 times x is x, negative 1 times 2 is negative 2, and we have negative 8 there, all over x plus 2 times x minus 2 is less than or equal to 0. Combining like terms in the numerator, we will have x squared minus 3x minus 10 all over x plus 2 times x minus 2 is less than or equal to 0. Now, as you can see, this quadratic expression here can be factored. So we have x minus 5 times x plus 2 all over x plus 2 times x minus 2 is less than or equal to 0. Now, as you can see, x plus 2 here and x plus 2 there can be eliminated, leaving only this one. So here, leaving only x minus 5 over x minus 2 is less than or equal to 0. Now we already have a single rational expression on the left side. Now, next step is to find the critical points. Again, all we need to do is to look at the numerator first and then the denominator second. First, x minus 5. We have to equate this numerator to 0. So x minus 5 is equal to 0. And x there is equal to 5. Next, look at our denominator. This denominator here cannot be equal to 0. Because if this denominator will become 0, our inequality will become undefined. So again, we have x minus 2 should not be equal to 0. Then we have x should not be equal to 2. Next step is to graph these critical points in the number line. So we have here. And then we will put an empty circle for the critical points that should not be equal or should not be included, and shaded circle for a critical value that can be included. So we have here. Next step is to determine the sign in each interval determined by this critical points. So we have here. So in this side here, in this interval from 5 to positive infinity, we will select a number. I will be choosing 6. And then this 6 should be plugged into our rational expression here to find the sign of the function. So we have 6 minus 5 all over 6 minus 2 is equal to 1/4. Now observe that the sign of this number is a positive. Then put it here. Next, between this interval 2 and 5, let us select a number. Again, you may select any number. You can have 3, 4. I am selecting 3. Now then again, let us plug in this 3 to our expression here to find the sign of the function. So we have 3 minus 5 all over 3 minus 2 is equal to negative 2 over 1. Negative 2 over 1 gives us a negative sign. So let us put it there. Next, select a number from 2 to negative infinity. I am selecting 0. Then again, let us substitute this value to our expression here. We have 0 minus 5 all over 0 minus 2 is equal to negative 5 over negative 2. And this number gave us a positive sign. Put it there. Now you have it. Then we will write the solution. In writing the solution, let's go back in the sign or our inequality indicator here. And it says that this rational expression should be less than or equal to 0. And that numbers are negative numbers. Therefore, our answer lies in here. So to write it, solution set is from 2 to 5. But this is parentheses because 2 is not included, and this is bracket because 5 can be included. Or you may write it this way. Solution set is x is a set of all real numbers such that x should be greater than 2 but less than or equal to 5.
Again, let us pause for a while for a practice. Solve the following rational inequalities for 10 minutes. Answers can be found at the end of the video. Have you heard of the saying, there are so many ways to kill a chicken? In the same manner, in mathematics, there are a lot of ways how to solve a problem. The one that I teach you is one. If you have found another method, you may discuss it with your teacher. Congratulations in doing a great job on this topic. Before we end, I want to share with you one famous line from an American mathematician, Paul Halmos. It says, "The only way to learn mathematics is to do mathematics." Keep on practicing and I'm sure you'll get better. Again, this is Teacher Hani from Kama National High School, wishing you all good health and happy life. Bye!